Welcome to Techie Book. Today we are going to discuss about HashMap and its internal working. In Java interview, HashMap will play a crucial role. So keep watch till end of this video. You will definitely get very good understanding of the HashMap. Trust me. So let's get started with the HashMap internal working. So our today's agenda will be HashMap internal working. So all these concepts we are going to see in this video. What is HashMap? HashMap is stores data as key and value pair. Whenever we insert the data into the HashMap, it will store as a key and value pair. We will discuss all these points in this video. So we have a lot of methods in the HashMap. In this, these five methods we regularly use: put, get, remove, contains, see, and size. Suppose we may use contains value and other methods as well, but these are the methods we'll be regularly using. And apart from this, we should know what are the main variables in HashMap. We should know what is node, what is the size, capacity, and what will be the load factor and threshold. So if you see here, these are the things I'm talking about. What will be the default initial capacity? Definitely is a 16. And always see this point. It must be power of 2. We will see what is power of 2 and maximum capacity. This will be the maximum capacity of the HashMap whenever it is created. The default load factor will be 0.75. It will be a float variable. We will discuss this one as well in this video. Next, Treeify threshold. It is an 8. By default, it is an 8. So we will see when Treeify threshold will comes and what is the use of this one. The same way, Untreeify threshold as well. We will see this one. What is the minimum Treeify capacity? All these three fields will be very important. From Java 8 onwards, we will go through this step by step. These are the things we are talking about. Example case, suppose if we say node will be having capacity of 16. As we see, initial capacity of 16. The node will be having key and value. Apart from that, it has an hash and which is pointing to the next node, next as well. So we will see all of this in this video. And we can see size is 3. Suppose in the map I have added 3 fields, then size will be 3. 3 nodes are total. And capacity, as we see, initial capacity of 60. Load factor, threshold. Threshold will be calculated. Suppose we have seen over there, threshold will be 0.75. Now the threshold will be calculated here. 16 into 0.75. The threshold will be 12. What is the threshold? We also will be discussing. And key feature, I can say this kind of drawbacks. HashMap is not a thread safe. Use concurrent HashMap if you want to go with the thread safety. And order is not guaranteed. If you want to be in specific order, use linked HashMap. That will give us specific order. These concurrent HashMap and linked HashMap we will see in the upcoming videos. I will definitely post a new videos on concurrent HashMap and linked HashMap. So why HashMap is not thread safe? Order is not guaranteed. If you see here, there is one node will be created and thread 1, thread 2 trying to operate on the same node. So what will happen? The race condition, data corruption. Suppose consider here a HashMap. T1 is trying to add the data and T2 trying to remove the data. And this data, whatever it is, will be corrupted. So this is what not a thread safe, because the best way is we should go with a synchronization of map, that is like synchronized map method will be there in the collection. We can use that making synchronized and we can make it as thread safety. In that case, the performance will be very low. If you use synchronized map, this hash map, and every method will be synchronized, in that case, the performance of the hash map will definitely decrease. So this we will discuss when we are discussing about concurrent hash map. Why the performance will be decreased comparatively concurrent hash map. Now, order is not guaranteed. hashing and resizing. Whenever we create a hash map with some data, it will always works based on hash code. We don't know the index which will generated by the hash code. Sometimes it's created index 1 and sometimes it will go to index 3 like that. We cannot guarantee that where that variable will be stored. So that's the reason order is not guaranteed. If you want to see this, let's go and create one hash map order. Now see, we have added the data into that order from 0 to 20. But when we are printing, the first value will be printed as 1, then 2. After that, you can see 0. After that, 5 and 6. Like that, it is created. There is no specific order will be created. As we discussed, if I go to linked hash map, and if I run this, you can clearly see that order is coming in the proper way, the way how it is inserted, the same way it is retrieved back. So we can say that hash map is not guaranteed by the order. So we will discuss about this in detail later of this video. First we'll see what is hash map internals, table, buckets and nodes. So these are the terminologies we should know. What is table? The table is nothing but an array will be created. So array of 16 nodes will be created. So we can see here 0 to n minus 1. As of now, initial capacity is 16. So 16 nodes will be created. This is called table. And each index, suppose 1, 2, each index will called bucket. In this bucket, the node will be inserted. So this is node of array means list of nodes will be there. Each one will be called as a node. Here each index will be called as a bucket. In this bucket, the node will be created. For suppose if we can say node here, node is a one kind of linked list will be created. So each index here will be a linked list. But node will be consisting. Here you can see key, which is stores as a key. Suppose if we insert the data into the map, the key and value, that is the key. What are the key we are inserting? That is called as a key. It stores the key and value. What is the value we are sending? And hash, as we discussed, hash also will be added into that node. What is hash? Based on the key, it will generate one hash code. Based on the hash code, it will find the index. Based on the index, the data will be added to the specific index. Each index stores the reference to the first node. And next to node pointer, I have a bucket. Now I got the same hash code. First time I got the hash code as 1 and the next time I got the same hash code. In that case, it should be added into that same index but after that bucket. Suppose this bucket was there, this bucket, and after that this bucket will be added. This is called next node pointer. This node which is pointing to next node and this node which is pointing to next node, these reference will be stored here. This reference will be stored here. This is concept of linked list. If you know little idea about linked list, you will definitely get understand about this one. Even though if you don't have an idea about linked list, we will be having next node address into this one which is pointing. So while retrieving, we can get all the data. We need some connection between that. That is called linked list. When that hash map will be initialized, suppose I have created map equal to new hash map with initial capacity. Uh, I have created with the default capacity of 60. What will happen in that case? It only initialize the values. It will not create any table for us. Nothing will be created. That load factor will be initialized with 0.75 and threshold will be calculated and table equal to null. Bucket array is not allocated. Here, employee object, I'm storing it as a key. String, I'm storing it as a value. To see in practical, I have an employee map. I just created with a new hash map. I have not added anything into the hash map. Now, here I have written some code which will read the table. By using reflection, I'm just reading the data from the table. So now see, when I run this, I have created a hash map. The length of the table will be 0. When it will be allocated, bucket array is only allocated upon the first put operation. This is called lazy initialization. Why? Because to save some memory, the Java people has created like this. Only upon the first put, the memory will be allocated. Now I can see the first put call, lazy allocation, the importance of the hash code and equals also we will see. I have a map added new employee value as a string. Whenever I put the data into that map, the lazy allocation of bucket array, the bucket will be created with the default capacity of 16. As we discussed already, the default capacity of the map will be hash map will be 16. Here, hash that new employee I have created without hash code and equals method. Now, the hash code, the default hash code method will be called from the object class. You can see here, object class hash code will be called memory address based. The hash code, suppose for example, this is will be created, not deterministic. Index calculation, suppose we got the index of 7. With this employee key, after creating the hash code, then we generated the index which is 7. Now, placement of the bucket will be 7. Whatever the index will be created based on the hash code, in that node will be added, not the employee object. That node which is having key as an employee, value as a developer, as we can see here, key, employee, value, developer, and hash which is generated here. This is the hash code will be added apart from that next node pointer. Now as of now, only one is there. Next node pointer will be null. Warning: without the hashcode equals method, you might never find the entry again. A subsequent get of data, you will likely produce a different hashcode. Obviously, we'll get a different hashcode. We will see this now in practical example. Here, I have a map. I have just added one element into that map. Now we will see size of the map will be 60. As we can see, length will be 16. Upon the first element which is added to that map, then only table will be created with the default size. The table will be created with the 16 and index that can be added to the anywhere, that we cannot guarantee. If you want to see that, now see here, it is added into the bucket 10, the index 10. The data, whichever data we have added, that is created in index 10. So we cannot guarantee the order anywhere in the bucket. It will be created based on the hash code and index. And what is this warning? We'll see. I have created a map and now I'm trying to read that map. Now I'm trying to read same thing. Will I able to get? Let's see. The map data will be null because the hash code which is created here will be different than hash code which is generating by the get. So these two we will discuss in later of this video more in detail. Now how put flow, that insert will be happened whenever we send key. Whenever we send key as a new employee object, it will be generate a hash from the key. After that, find a bucket index. That is, we'll go with the some formula. Based on that one, we will create an index. If bucket is empty, that will be inserted into the bucket. If bucket is not empty, the collision handling will be handled here. It is based on the hash code. If I get the same hash code, The first time data will be added, and second time bucket is not empty, we have to handle the collision. And as we discussed, the first time it will be empty. These are all when we get the same hash code. Even though if we get a different hash code, definitely the bucket will be empty. Every time we get a different hash code. Suppose I have it like this. And whenever I put map.put a comma b, if it is generating same hash code, and it will always go to the this bucket, and it will keep increasing. And if I get a different, and first time it will go here, and next time will go here, and here. So every time will be the new hash code and new index. In this case, the collision will not be happen. Every time will be new hash code will be created. This also we'll discuss in this video in few minutes. Now, hash map storing key and value pairs. Suppose, as we discussed, I sent a key. Based on the key, the hash function will be called. It will generate hash code. Then index calculation will be happen. It will generate the index. Suppose I have got the index 5. In index 5, here the key and value apart from this hash and the next node. That node will be created here. And fast access via index is O of 1. Why? Because even by getting, we use the same hash code. It will directly go to the index 5. It will read the data. The complete workflow of hash code and equals. So we will be discussing about hash code and equals also we will see. Suppose I have a key which is generated based on the key hash code. It is called this method, and hash value is generated. And then it is calculated in the index, and I found here it is the index, the table. I have added the value. Okay, the first time I have added the value, and next time if I want to add the value, it has to check with the equals. Suppose I have generated the same hash code and it has the same object. What is the case? It should not create a new node for the same object. It should be update. That's what. If equals is compatible, then match will be found. Get and will update in the value. If it is not equals, then no match. A collision, it will append the new node. Suppose I have added the map.put. Instead of this one, I use the same thing. Here I added the same value. Again, I put map.put e comma value 2. Now leave about map data. I have not added for here. If I want, I need to use same. Now you can see map data will be value 2. So value will 1 will be updated with the value 2. Here equals method will plays a major role. It is generating the same hash code. Based on the hash code, it will generate the index, and it will try to update the data instead of creation. Now size of the map will be 1. It should definitely 1 because we have sent the same one which whatever that is created. One time hash code will be created, the same one will be passed. So that's what. It uses equals method and it is not matching. Suppose in this case, I have one more hash map which is having employee object, and hash code I will be returning always 1. And whenever equals method will be called, I will be returning false. Those two objects are not equal. So what will happen? Now I can see the size will be 2. Suppose in this case, if I just return true, I can say both are equal. And hash code, you see here, hash code also same. and both are equal. Now size will be become 1. See, the size will be 1. Why? Because these are all equal by equals method and hash code will be the same. If you go to the contract, but of the key we have passed, it is equal to the key which is already present. So match found, then we'll update in the data. Next time we return false. In this case, no match found. In that case, new will be created. That's why we are seeing size as 2. Duplicate key check. It always go with the true. Existing key, it is already there. It will update the value. If it is a new key and adding a new node. This is how HashMap avoid duplicate keys. Whenever we found a key, we will update. If no key found, we'll create a new one. The hash code and equals. The hash code, which is a decider of the bucket index, equals confirms the same key or different key to eliminate the duplicates. Both are required, definitely required to correct HashMap behavior. See here, the key generating a hash code, this hash value based on index it founding decide the bucket index. It is conforming equals method. This key and whatever the added into the map, both keys are same or different to compare the data. Why? Because the key should not be having duplicated. That is the reason equals plays a major role here. Both are required to correct the hash map behavior. This is the contract. Suppose if equal, hash code must be the same. If two objects equal, suppose I have a equal to 1, B equal to 2, C equal to 3, D equal to 4. Now I am planning to add C equal to 5. Now I found key will be the same here and here. When I generate the hash code, if I get a new hash code, suppose this hash code is something like 123. Now for the new object which is having same key of C, I got new hash code of 1 to 7. Where it will store? It will store here, which is C equal to 5. This is definitely wrong. Why? Because these two objects are equal. Why we can say if equal? How we can say? Based on the key comparison using equals method. By using equals method, this C and this C both are same. If I generate a new hash code, the data will be added here. So duplicate keys will be added. That is the reason. If both objects are equal, hash code must be same. The same way, if hash code same object may not be equal, we'll see. So I am sending D equal to 5. Now I got 1 2 3. Same hash code of 1 2 3. Will it replace this value with D equal to 5? No. What will happen? It will create a new node with D equal to 5. I have E equal to 7 with the same hash code. What will happen is create a new node E equal to 7. No duplicates was there, so nothing is impacted. So that's what hash codes are same. Objects may not be equal. So we don't need to worry much about it. The hash code must be consistent. If object does not change, calling hash code multiple times should return the same value. So whenever object is not changing, in this case definitely we will get the same hash code again and again. No, so nothing to worry. So equals hash code. If you see visual representation, I have a two keys that equals to true. The comparison will be true. It should be having same hash value. That is mandatory rule as we discussed earlier. And if hash codes are same, objects may not be equal. These two objects are not equal to, then hash value will be same. Yeah, no problem. Load factor and resizing process. What is the initial capacity? by default 16. The load factor will be 0.75. The threshold formula, what it is? Capacity into load factor, that is 16 into 0.5, 12. A resize is triggered when the number of elements exceeded the threshold. Suppose I have a capacity of 16. I have a table which is having capacity of 16. Now I have inserted the 13th record. What will happen? It will check the threshold. 13 is greater than 12, definitely. And threshold is true. It resize happens. The new capacity will be doubled. Doubled with 32. It's always 2 to the power of n. Now it is 16. Next time it will go to 32. 2 power 4 to 2 power 5. Then 2 power 6. Then 2 power 7. Like that. Always it will be double the size. That is into 2. Here we can see capacity will be doubling. If it is 16, it will goes to 32. 32, it will goes to 64. Now, one more point. Now I have a hash map. I have created a hash map with the initial capacity of 3. Now, what will be the size of the table? The size of the table will be 4. When our initial capacity will be created, it is always 2 to the power of n. The next value of the 2 to the power of n will be considered. That means 4. The table length capacity will be 4. Even though we have taken 3, the capacity will be 4. Suppose I have taken 23. Now, what will be the next value? 32. So, even though you have taken the any value, it will always consider next value. And again, it's always 2 to the power of n. After taking 32, it is always multiplied by the 2, the next value. So that's what. Whenever the size will be increased 16 to 32, the redistribution is called rehashing will be added. Here you can see HashMap resizing. I have a capacity of 16 with the load factor 0.75, threshold will be 12. This is the one. Now threshold will be this one, which is 12. Added the 30th element. Now new capacity will be become a 32. Load factor 0.75. Now new threshold will be 24. That is 22 into 0.75. The size 13. Old threshold 12. Resize is triggered. Now this is the old bucket. Now we are completely created a new table, which is old table. From this completely new table will be created with the size of 32. Again, all existing element will be rehashed. Even though it is cached, everything will be created. Everything will be created, capacity, load factor. If we found the index after resizing the hash map, it will again created a new hash code and index. It will be added the element based on the new index. Suppose if you want to see by example, now I'll be adding 12, 12 records. So now we can see here, initial size of the capacity will be 16. The index 4, 6, 8, 9, 6, 8, 10, 12, 14 will be added with the data when the new hash code, sorry, new table which we created with the length of 32. See, bucket 0 also be added, and bucket 1 will be added, and 4 will be become a null. So it's again created with the new hash code, new indexing. Whenever the capacity will be increased, the new hash code, new indexing always again will be created, and the data will be stored based on that index. So that's what here we're telling the new hash code, the new bucket array will be created, all existing element will be rehashed. So now we'll talk about hash collision. What is hash collision? As we discussed, same hash code again and again, then we will get a hash collision. Suppose in this case, I'll be returning every time with the 42. That means the hash code will be the same. If you see here, this is the table which is having bucket size of 15, suppose 16, sorry, and the index 10 every time will be returned because the same hash code It will be generated with the same index, and in the same index of 10 we have created a linked list, the node which is pointed to the next node, like that all the new records with the same bucket index due to the collision. The hash code will be the same. It should be added to the same bucket. It will create a new linked list in this bucket. So that's what we will be having here, employee object. So every time it will be written same hash code. Let's say equals to false. Why it is false? The object should not be the same. Now let's see, the hash map node will be created. If you can see here, this is the node which will be created. Node will be created and capacity of 16. So it is always go with the go and add it into the same index. So this is how this will be created. Everything will be created as a linked list. Now suppose I have a bucket array size 16 and linked list at index 10. Suppose I have added 9. That here we can see the Treeify threshold. As we see here earlier, the threshold of the Treeify threshold will be 8. In this case, I have added the node as 9, the length as 9. The linked list size reaches the Treeify threshold. It is greater than whatever it is default. Adding the ninth element triggers the treeify bin. There is one method which is treeify bin, which is called threshold is 8. So this treeify bin will be calling resize method. You see here, this put value method bin count is greater than treeify threshold. So whenever the bin count is reached, that value is greater than, this is the bin count, this is greater than treeify threshold of this one, this will call treeify bin method. This treeify bin method will do resize. What resize will do? It will increase the old capacity by, so that's how whenever we see, when we added the 9 here, the size will become 32, the bucket array. Why? Because this from Java 8 onwards, this list will be converted to tree. That's the reason. If it is more than 8, Java people has created a condition. If it is more than 8, go to the tree. There is one condition. Even though it is more than 8, the bucket array should be greater than 64. Whenever the bucket array, suppose it has a 15, after adding the 9, it will become a 32. Still, even though it is tree threshold is greater than 8, it will not convert to tree. Why? Because the bucket array says still 31. It should be greater than 64. Then only it will be converted to tree. As of now, tree threshold is 8. Now this will be added. The size of the table will be 32. If you want to see clearly, I am setting every time same hash code and that object always false, means both are not same. Suppose I have added 7 records. Now see, the bucket class still it is a node, which is node not yet converted to tree, and size of the capacity will be still 16. Let's increase the size. Let's move to 8. Still the same size will be 16, the table size. See, whenever it reaches map size equal to 9, the size will be increased like this. Whenever ninth element will be added, the size will be increased to 32, because the treeify bin method will be called, because the threshold will be reached. It is called in resize. Then the size will be increased to 32. Suppose I have another element, next element, which is 10. Adding in another element. Definitely, the new bucket array size will be 64 from 32. Let's see. I have added one more element. Now size will be increased to 64. Also, every time whenever we add the data into the node, into the same bucket, it always check threshold, which is greater than 8 or not. If it is greater, suppose I have an element 9, it is greater than, size is increased to 32. Again, I've added 10. This time again it will go to checking the threshold. It is greater than 8. Again, it will call Treeify bin, it will go to resize, and the old capacity will be doubled with the new capacity. You see here. What is collision handling? Linked list versus balanced tree. And size should be greater than 64. This bucket size should be greater than 64. Suppose here I have these many elements. Suppose linked list length is 7 and bucket size is increased to 64. What will happen? All this list will be converted to balanced tree. Treeification condition is a linked list converted to balanced tree only if the length exceeded 7 and total hash table size is greater than 64. Then only linked list will be converted to balanced tree, that is red black tree. Linked list to red black tree will be converted if bucket nodes become large, convert to red black tree. This is the condition. It should be greater than 8, the tree 5, and table size, which will be greater than the size 64. If it is red black tree, what is the benefit we are going to get? The search improves to O of log n. If it is not tree, then the search will be O of n. That is the reason it will convert into red black tree from Java 8 onwards. And Treeify we will explain end of this video. Now, I have added 10th element, which is 64. When adding 11th element, it triggers the Treeify bin since the capacity is greater than min tree bin 64. The list is finally converted to red black tree. If we want to see practically, now it is 10. I increase it to 11. See here. Now it is converted to tree node. What is before? Before it was node. After increasing the size, it is converted to tree because it is satisfied the condition of 64 and also it is satisfied the condition of threshold. It is satisfied the condition of Treeify threshold and it is also satisfied the condition of minimum tree capacity, Treeify capacity. So this is what I said we can discuss later. That is the bucket size and this is the collision, the bucket linked list size. If you see clearly here, this is the linked list size and this is the bucket size is 64. Ignore about this 15 and 32 because it is not generated properly. A new bucket array size, consider this 32 and 64. So adding the 11th element, now we can see clearly 0 to 63 whenever we add the element of 10. So when we go to the 11th element, it is converted to linked list to red black tree since the capacity now 64. That's what we have seen in practical here. Now we will discuss about Untreeify, converting back to linked list. Whenever the red black tree nodes is lesser than equal to 6, convert back to linked list. If bucket nodes reduce to 6, it will come back to list. Optimize memory and performance. This is the what we discussed about Untreeify threshold. As I have shown here already, whenever I decided to go to 8, I ordered only these elements. Now it is a node only, converting back from tree to linked list. That's what is happening here. So HashMap state and bucket size will be 64 and 10th will be having red black tree. Whenever we remove from the red black, Untreeify threshold will be 6. The final state converting back from tree to linked list. That is called resizing. And one more thing. Suppose in the index one I have added 8 elements. Next, from the next element, I have added with a new hash code. In this time, I have added to the index 2. In the index 2, that object will be nodes will be created. Last time, index 1, all the nodes will be created. It is not crashed the Treeify threshold. Consider now I have given the new hash code. So here it will be created with this index 2, all the nodes will be created. So it is different hash code added to the new bucket. So bucket 1 list size remains 8, which has not exceeded threshold. Therefore, 35 will not called. Why? Because it is not crashed the threshold. Consider it is not 8 element not added. It is not crashed the threshold. The final state of the capacity 16. The capacity will not be changed. Why? Because no resize method will be called. It is added to that next element. Next index the data will be added until this will go to more than that, or this table size will be increased to more than 64, and also this threshold will be increased, then only that will be converted to tree. As of now, bucket 1 will be having only 7 records. So consider 7 records is safe, not converted, and index 2 will be only 6 records, and also no need to convert. So it will not call Treeify, it will not resize the capacity. Consider I'm having 8 here, the size will be 60. I will return. So whenever id will be 5, I am passing anyway some id here 0 to 8. Whenever id will be not equal to greater than, whenever greater than 5, that hash code will be 9. Create a new hash code whenever that id will be greater than 8, 5. I have given 13 here. See, the table length is capacity of 32. Why? Because it is crashed at the load factor more than 12. The initial capacity will be 60. I have given 30. It is more than 75%. So it is created with 32 size. Last time, when we added the 9th record, 10th record, it is going to 64. This time, it is in 32. If suppose if I give 12, the size will never be changed. See, even the 12, the size will never be changed because I sent new hash code. In this case, bucket 1 will be having these 5 records, and bucket 2 will be having remaining records because it has a different hash code. That is the reason the size no need to increase because it is not crashed. Only one null key will be allowed into the hash map. So how the data will be stored? Maximum one null key will be allowed, and null key always goes to bucket 0. Every time if you pass null, it always hit into the bucket 0. Value update. Reinsert in the null key, update the value. Suppose if we add one more null, it will be update the value. What is the case? Already bucket 0 will be filled with some data. Nothing to happen. It will create a linked list. In the same bucket, new node will be added. That's it. So get null case. Key is not present. Get will returns null. Suppose key is not there and value is null. Definitely get will returns null. What are the cases? Get will give null case. Key is not present or value is null. Best practice before going to get use contains. Now get flow. If key is null, it will go to bucket 0, check the bucket 0 and get the value. Else, generate a hash code, compute the index. It will generate the hash code, compute the index and get the value. So search the bucket using hash match and equals. Definitely, whenever collisions will be there like this, it will go to index and then equals. We should use equals method to get the value. Linked traversal research. Linked list traversal will be like this, and tree search will be like this. Tree search will be O of log n, linked list will be O of n. The get time complexity versus linked list and red black tree. The time complexity, the worst case O of n. The time complexity of red black tree O of log n. The, the one which we discussed earlier.